Okay. This is DPRG's April 26th Robot Builders Night Virtual. We've been doing this now for over a year, and we are a little unusual tonight because our president is not in it, but we got somebody here that's not usually here. Hi, Scott. Um,
Hey, Doug.
so anyway, I'm recording this. If you don't want us to be seen, blank your video and don't say anything, and you can still watch it. Okay. So Ray's already jumped on first. Ted's got some news. So we're going to start off with that. And so Ray, go ahead.
Okay. I have video to show. Do this. Screen. Share. Okay. Can you see that?
Yep.
Oh, yeah.
Yep, it's a new platform I've been working on, doing the machining on.
I can see your parts in it.
Yeah, these, the different plates that hold the bearings in and stuff. Anyway, I don't know how long it is. Oh, it's 2 minutes.
So how big is it roughly, scale-wise?
Well, the wheels...
The pictures look big.
Center, there's as square as I could possibly get it. So from wheel center to wheel center, it is 11 and let's see, 5/8, 10. I think it's like 11 and 5/8, or yeah, 11 and 5/8 in either direction, and that was based on pretty much the chain length. If you're replacing the links, you could use what they call half links or full links, and a half link is, gets you like one adjustment of the pitch of the chain, and a full link, you have to go 2 links, because that's just how they work, or how they join together. Anyway, let me see if I can play this. Oh, the thing is right under. Let's see if I can just start it here. I can't believe it.
Is there a hide button right beside the stop sharing?
Oh, here we go. Gotcha. Four-wheel drive with 2 motors, so more or less a skid steer. It's got 10-inch wheels, and each wheel has a big plate hub. And this is not welded to this yet, but I'm going to weld it here shortly. Anyway, once that's welded, these are keyed shafts on all 4 wheels, so that will tie basically the wheel to whatever shaft, either motor shaft or other shaft. Anyway, there's the 2 motors. It's chain drive. There's bearings, 2 bearings for each back wheel, and 1 bearing for each front wheel, and it also relies on the bearing in the motor itself. Each motor shaft was turned down. It was about 7/16 in diameter, and I turned it down to 1/4 inch, cut it off, and so each shaft kind of looks like this. It's got a 1/4 inch hole that's drilled out and reed. There's the 2 bearings. Each bearing has 2 screws that hold it in here and down there. Each wheel on the inside, made of aluminum to make the difference between the half-inch shaft and the okay, now I can put it back on. The half-inch shaft and the 3/4 inch high-grade wheel. And I'm going to put a front bumper on it. I haven't cut it off yet, but that's basically what the front bumper is going to look like on the thing. So that's what I've been working on.
Ray, that's a big front bumper, isn't it?
Oh yeah, it's pretty big. It'll cover just above the wheels.
Mm-hmm.
So I can make a box out of it.
Mm-hmm.
One of the things I didn't say. Let's see here. Okay, these two little. I don't think you can see the other one, but this little hole here actually pins this shaft onto the motor shaft. So those are, it's like a roll pin. It's actually like a spring steel piece, and you can get them in different diameters. That one's 1/16. So that goes through this shaft, and and through the motor shaft that's sticking in that hole. Was what I didn't say.
How are you going to handle chain tension?
Well, this is like a 1/2-inch piece of plastic. It's like 2/4 inch pieces that are glued together.
Mm-hmm.
And the tension on this side is adequate. The tension on this side is just a little bit looser. One of the things that I found, if I can bend or just distort this plate a little bit, it puts tension on the chains. So basically, I'm curving the plate and kind of pushing the two sprockets away from each other.
Yeah. Okay.
As it's curved. So I think I'm going to try that. It's kind of like it's definitely a learning experience. I mean, if I had to do it again, I think I would get like a 2-inch by 2-inch U channel and just use 2 long pieces of it.
Mm-hmm.
And cut out what I needed to out of the U channel to accommodate. Really, the only cutout I have to do is for the motor, the body of the motor.
Mm-hmm. Mm-hmm.
And I think that would make mounting and tension issues, chain tension, a lot easier. And it, black plastic out in the sun, it may even sag and get a little loose. I don't know yet. But,
the chain wears too. It wears a lot.
Yeah. Kind of on the initial run, you'll get a little bit of stretching or whatever they refer to it as.
And if you pull, I guess in this design, if you tighten it up with slots on the
pull these forward.
It would change your wheelbase.
Yeah.
Okay.
Yeah.
Mm.
Yeah.
Have you ever looked at how I forget David has shown pictures of how he's done that. You might want to look at his rover and see how he handles it.
I think he had idler wheels, didn't he?
Yeah, but I want to say he's now belt, but I don't know if he was always belt. I think at one time he was chain. Right now,
he's
I
probably
think.
got like a tensioner wheel.
Yeah.
Or sprocket or whatever. Yeah. Anyway.
Cool. Very cool.
Hey Ray, that's a lot like the new version of Burp, because I have basically chain drive, with a motor driving one sprocket and then kind of a trailer wheel. And I thought there's some I can't really show you, but there's a couple of bolts here on the side, and there's a little swing arm right here that I use to tension the chain, and that came from the Circuits or Servo City. Some of their hardware It's like
okay.
all of Circuit Cities or Servo Cities hardware, the hex shafts and the bearings. Very similar setup to what you've got there.
Oh, okay.
Um,
So Servo City, huh?
yeah, so there's and it's like a little idler wheel and a little bracket, and you basically loosen one of the bolts up and you can tension the chain, because like Doug was saying, when you first start to break that thing in, the chains actually stretch, or they basically wear in.
Yeah.
And they'll start to get a little sloppy.
Mm-hmm.
So that's what I put on here to rectify that. Plus, like you were saying, I agree with you. I would have used a single channel to put both wheels in, because I basically mounted mine to the base here with a similar arrangement, like I was saying. And you had to really calculate the shaft distance, because
Yeah.
like you said, you only have a half length or a full length that you can play with.
Right.
So, that's even with the belts, like David's. Doug was saying, David has some idler sprockets on his belts even.
Mm-hmm. Yep.
So it's always a good idea to have some adjustments there.
Yeah. Yep.
So
yeah, I was even thinking of a name for it. I think I'm going to call it SGRB, which stands for Scott Gibson's Robot Beater.
Oh, do I hear smack? Smack.
As long as you don't cheat and stretch the rules again.
Hey, rules, it's guidelines. They're flexible.
Yeah, tell him about the guidelines, Doug.
Yeah.
Hey, I wanted to, Doug, I was watching part of the video from the last meeting, and you were mentioning a contest.
Yes. In June.
Give me some more details about that.
Well, right now we're only going to run contests that people say they'll participate in. So right now we're definitely going to do a four squares, because everybody kind of wants a post COVID navigation reset to make sure they can do it. So that's one. Also, that one is real nice for people that aren't in Dallas. They can run it at their location. There's also going to be a sample retrieval. If Kareem has said that his team can run that. So if you look at the website, it's basically you start in a square, and there are 5 objects, and 4 of them are real easy. They're like, well, they're not easy, but they're like a soda can, a baseball, a toy block, and something else. And then there's a little Smurf doll. And so what it's really aimed at is people who are starting to do object recognition. So if they can see it, and they drive to it, bring it back to their home base, and in that perfect world, you'd bring all 5 of them back to the home base. And depending on how we're doing it, we'll start off easy. You'll probably all 5 of them will be where you can see them, but then later on they'll probably be they'll be in the room, but you won't be able to see them from your home base. It'll progress and get harder as time goes on. But right now, I'm not sure. It depends on what Kareem tells me he can do. So those are the 2 we got. You got Ray and you. Do you guys want to try another can soccer, or not? What's the other one? I can't remember.
Yeah, 6-can.
6-can. We know I probably try to want to do a 6-can first. Is that something that you'd be interested in?
Sure.
Yeah.
Okay.
I'd like to. I think I want to play around with one of those new SparkFun sensors, a little one with the multi-zones on it.
Okay.
See what I can do with that.
Okay, so I'll add that to it, and I'm going to post it here on the competition web page probably this week. My wife has started a new clinical trial, and so things have been a little weird the last 2 weeks, but that's after the first 2 weeks, it kind of settles down into a routine. So I'm going to, I'll get the competition page up this week.
Okay.
Okay, so, all right. So Ray, one of the things I was thinking, if you can pin me so I can look big.
Sure.
All right. So create a piece of shafting or wire or bend it, whatever you want to do, so that it's a U like this. All right. So think of it like a tailpipe muffler clamp. Okay.
Okay.
So you put a nut that's screwed on the two ends. So you put that into your base and then screw on the other end. And on the top, otherwise on a muffler it's round, but you'd want it flat. You put just a 3D printed sprocket to fit on your chain. And so to tighten it up, all you would do is go down, push it up.
Yeah. Yep.
So anyway, that's a simple way. It's an idea.
Okay.
Okay.
Yeah. I don't. I know, like on bicycle chains, because they have a fair amount of tension on them. They'll definitely stretch. And just wearing in the individual rollers in the chain, I'm sure they'll give a little, as far as loosening up. But I'm hoping it doesn't, lose a lot of tension. So.
Well, every time I've messed with chains, I've always been surprised at how much they stretch.
Yeah.
Because you're saying, oh, I'm really not loading this up, and look at this. This is monstrous steel, and it's a half inch, 2 inches longer than it was when I started. I don't understand it. I mean? Well, a big chain. So yeah. So anyway, something to think about.
Figure, all the contact points, and you start getting a little bit of wear in each one of those individual contact points, and they start adding up. Everything stretches quite a bit. When I first built this, I had the chain pretty much tight, and then after maybe 20-30 minutes of running, which really isn't much, I had to adjust the tension. Now I expect that to decrease over time, so as it wears in and the surfaces start to mesh, then it's going to be fairly stable. But until you get that time on it, it's just not going to be stable.
So you use the sides to hold, what do they call those things? Like pillow blocks or something with a bearing in it?
Well, the side, keeps the distance, but it's ultimately everything is mounted off of the base, because the sides are just like, 18 gauge aluminum, and the base is about 1/8 of an inch thick. So everything is center, is basically the structure is in the base.
Okay.
But it flexes quite a bit, the whole box, because it's just aluminum.
Right. Yeah. Yeah, I was really disappointed. I tried, I think they're called Aluma-Weld rods. And
I've seen those.
Oh, have you?
Yeah, how did they work out? I've never tried one.
Didn't work at all. I was really disappointed. I don't know if, I thought that was like, I think it's 6061 alloy, which I think is like one of the most common, aluminum alloys I think that you can get. Anyway, they had a little video and they showed the guy, he's, more or less brazing with these rods and, just propane torch. And propane torch definitely melted it, but it didn't stick to the aluminum at all. And then I got the bright idea that, okay, maybe my propane torch wasn't hot enough, and the only other torch I have is a plasma torch, and the plasma torch is so hot that it just like liquefied the rod and blew it all over the place. It didn't, it wasn't really controllable.
Ray, you're doing it the wrong way though.
Do you need flux?
No, what you really need with that is you got to realize it's sort of like soldering, okay?
Yeah.
So you have to heat up the thing that
The
you're
pieces.
you're welding or you're soldering. It's
Right.
not, you actually don't apply any heat to the rod.
Yeah.
You get the base material that the two pieces you want to do, you get them up hot. And
Yeah.
then when you can melt, then it'll wick the two pieces together. And it works really well if it's done right.
Oh,
I mean,
really? You've tried
yeah.
it?
Oh, yeah.
Yeah.
I used to have a motorcycle and I used that stuff.
Oh,
So,
okay.
yeah.
Hmm.
It's super critical to get the aluminum good and clean and prepped.
Yes.
Any
Yeah,
kind of dirt
I
or
did that.
residue or oil, and you can
Yeah.
forget it.
I
Yeah.
sanded it. I, filed it. I was trying to think. Okay, maybe it's not clean enough or something, but still, it didn't stick.
Yeah. Try it on something, besides your robot. Try it on a couple of scrap pieces. But
Yeah.
try to get the heat. Because, aluminum, it's pretty hard to heat up.
Yeah.
Even though you can do that with propane, if you really got any aluminum there, you might have to use MAP gas.
Oh, okay. Just a little hotter.
Yeah, a little hotter.
Mm.
But you shouldn't. Yeah, I mean, you can do it with propane. It's just the
Yeah.
question of can you get the piece hot enough
Yeah.
to do to. It's almost got what you want to do is, like I say, you want to get it. You want to get the surrounding material hot, and then the area where you're actually going to put it, you want to get it hot enough to melt the stick.
Yeah. Okay.
And like Scott said, it's got to be really clean.
Yeah.
Yeah.
Yeah. Well, maybe I'll try it again.
Yeah.
Yeah, I bought a propane cylinder. Seemed like some of the places are having a hard time stocking that stuff, like Ace Hardware.
Right.
Yeah.
Do you have a wire welder? A little bitty wire welder, one of them cheap ones?
I've got a Miller-Matic.
Because you
You
can
know,
buy all the
yeah.
gas for that and MIG weld with that aluminum. I've done that. It works just fine.
Don't you have to have a spool gun for it?
Yeah, a little. I got one of them little. One of them little wire welders you bought at Harbor Freight
Okay.
and bought a bottle of gas for it. I forget if it was argon or argon slash CO2. I forgot which one it was. I mean, I got
Yeah.
it in the other shed, but I've done some aluminum welding here at the house with that stuff.
So you fed aluminum wire through your MIG gun?
Yeah.
Oh wow. Huh.
Yeah, aluminum spool with. I mean, it's got to be able to set up for heated arcing. I mean, you got to be able to put some argon to it. But
Yeah. Yeah, I've got that. Yeah.
you can buy that. I used to be able to buy it at Home Depot. I hadn't bought it in years. But
Oh. Okay. I'll
it's
look
be
for
about a
that.
little bitty bottles, man.
Oh, I've got one.
When
I don't know.
you use
5
the
feet tall.
aluminum, did you run it through the full MIG cable thing, or did you have it as a separate?
No, it came with it when I bought it. I'll go take a picture of it here in a second. Bring it
Okay.
in, present it to you guys.
Yeah, I've
It's
seen.
in the other, it's in my other shed. So I'll be back in a second and I'll show you.
Okay.
Okay.
Go ahead.
Yeah, I've seen setups where you attach a separate spool, spool. They call it a spool gun, to it or to your MIG welder.
Yeah,
I've seen
that's
that.
what I've
I didn't know
seen.
you could buy. What?
I've seen
That's
YouTube
what I-
videos where they've done it without a spool gun. But you're
Oh,
right.
okay.
Spool gun is the accepted way of doing it.
Oh, all
You
right.
know,
I didn't
so
know.
anybody who's does this stuff more than just for a home job is going to
Mhm.
use a spool gun. Apparently, it's a lot easier. But,
Yeah.
but I have seen, if you go out on YouTube and look for aluminum MIG welding without spool gun,
Okay.
there'll be, if somebody will be doing it, but you have to judge whether it's worth your
Yeah.
time and effort.
Yeah. Didn't know you could do that. Yeah, spool guns aren't cheap. think the cheapest one Harbor Freight sells is like over 150, and they have another one I think for 250 or around there.
Yeah, but just think, then you could do it forever.
Oh yeah.
I know, it's always something, isn't it? Okay. All right. So, are you finished, Ray?
Yeah.
Then we're going to go to Ted and let Ted give his news here. So, people who've been following.
Yeah, okay, so the contest that Jesse and I entered for the Lego Oak D Light robotics build, they had the judging last Thursday, I think, and we made it to the top 10, but not the top 5. So we were a little disappointed, but happy to be in the top 10. Yeah, thanks. I think the judges, just seeing what they picked for the top 5, they were more interested in like robotic arm type things where the Oak D Light was identifying objects and picking them up and moving them around, that sort of thing.
Mm-hmm.
How many contestants were there?
There were 50 total.
That's pretty good, Ted. I mean,
Yep.
yeah.
We
Plus, you got the project done, which that's always a big one.
Congratulations.
Yeah. For any of you who don't know, we did a robotic self-driving car project. I have it here. So this is our Lego car, and we did that because we knew how to do that. That's kind of what Jesse and I have specialized in doing. So we had a lot of fun doing it, and Jesse worked on a lot harder than I did. He's very motivated to do robotics projects, so he's fun to work with because he gets a lot done.
Yeah. Mm-hmm. Well, his talk, which he did this month for the second Saturday, was very well presented. I learned a lot that you guys went through that, both of you. But I show them that car again.
Okay, yeah.
That's Legos, guys. That's not, it's all Legos.
Yeah, it's a Lego kit.
That's
In Jesse's talk, he showed us a pile of Legos that began as.
Yeah.
And they're no big parts.
Yeah, it's all Legos.
Right. I think it was, I don't remember, something like a couple thousand pieces.
Yeah. So that's pretty amazing.
And it wasn't quite as easy as you might expect because we quickly deviated from the plans that Lego provided in order to change things so we could put motors in and steering wheel servos and leaving room for the other parts we needed. So there was a lot of work redesigning the Lego kit.
Doug, do you have something ticking in you?
Okay. I don't know. I think I mentioned this last week that I've been picking up kind of a new side hobby of playing with alarm clocks. And so right now I've got a stack of alarm clocks over here ticking. I'm sorry.
That's what it sounds like.
Yeah. I've turned it. I found out that watches are too small for me. And then I tried travel clocks, and they're still too small for me. I can't afford the big clocks, and plus I would have no place to put them. It turns out alarm clocks are kind of the sweet spot if you just want to play with this stuff. So that's simple. Okay.
It's the good old-fashioned thing with the 2 bells on the top.
No,
One
I
of my
don't have.
hobbies is repairing
Don't have
cuckoo
any of
clocks.
those. Yeah. No, I don't
Hey,
have any
y'all
of
ever
those.
had that aluminum welding squared away, or
No, go ahead. Mike.
my rig? I know I presented. I've got it on Google Photos here.
Oh,
Okay.
okay.
I know I presented.
Go to the box with the arrow.
The one that looks like a box with an up arrow.
All right,
Click on that.
fire screen, and then
Now you have to actually click in the screen, in the box with the screen. You can't just click that I want to show everything. You have to click
Let me
in
do
the
something
screen.
here. Okay, hold on. I'm going to. It says block. Select screen.
Okay, so you hit your entire screen. Just hit it. Okay. Then it's going to show you a box with the screen in it that you're going to see. You got to actually click inside that box of the screen, and then you got to hit share. Got it?
Okay, see it now. Entire screen. Oh, there it is. Allow. Is
Still,
that sharing now?
no, don't see it. Not yet.
You know, I can do this the easy way.
Wait a minute. Something happened.
It's going.
There you go.
Okay, you sit down. Nothing, huh?
No, we have it. We have it.
You can
But
picture
you wanted
my
it.
settling? My wire. You got a picture of my rig there?
No.
Okay.
It's
well,
black, so you need to.
Click on whatever you want us to see.
What you have is your screen with our screens replicated.
I don't know. I don't know what I'm doing.
Yeah, if you look at your tabs up there, it says, oh well.
I
You
just
had
took
the
it
Meet
off.
tab selected when you wanted to select the Google Photos tab.
Here's a window. Okay, there it is.
Just try it again. Give it a shot.
Okay, it looks like
Okay.
it looks like it worked.
And when I try to present other ad, it doesn't work.
Yeah, I think you still have your Meet tab selected. Click on the Photo Google tab at the top of your screen.
Google
Yeah,
tab.
I think if you click on the Fold tab, it'll work.
Yeah, I keep moving my mouse. At the top left corner, it says Meet, and then it says Playing. So you're showing
Yeah.
your actual meeting screen when you want to be showing your photo screen. Or maybe even
Where's
the
that
option
at?
print. You
Yeah,
see
other-
way up at the top where it says File,
Otherwise,
Edit, View?
Huh?
Way up at the top of your screen where it says File, Edit,
Yeah.
View. Right below that, it says Meet, and then Octoprint, and then Photo. Click
Yeah,
on Photo.
yeah.
Click on Photo.
Okay. Do you see that?
No, it's still not showing
no.
us.
no.
We're still seeing your Meet screen.
That's weird.
Yeah.
Yeah, I've got.
Hmm.
Oh, there it is.
There you go.
Wait a minute, there you
Got
go.
it.
You got something
go.
now.
Yes.
That is.
Eureka. That's it.
Yep.
Mhm.
You can see it.
Yeah.
Well, you can see it.
Yeah, well, I ain't used it in a while, but that's it. You can see it's got a lot of dust on it, but it's got that argon rig in the back. I don't know if y'all talked about that while I was gone. And that ain't nothing but one of them cheap Chicago electrical whatever from Harbor Freight.
Yeah.
And I've welded aluminum with it in the past just fine. I'm just, if a guy ever wanted to go that far.
So
Yeah.
the key is
Oh,
you
there.
have to have the argon, though, it sounds like.
Huh?
It sounds like you have to have the argon gas, though, to run it through.
Yes.
Yeah.
Yeah,
I
you
do.
have to have the
Probably.
bottle on it. But here's my I'm gonna take it back off again now. Y'all did get to see the rig, right?
Yep.
Yeah.
So, it was welded. I mean, of course, you get what you pay for it. You couldn't, it's you bought just aluminum MIG spool, with that gas. I don't know if none of y'all have ever seen that like that before. I mean, in that setup, one of them small rigs like that.
The only MIG welding that I've seen is with a spool gun. You attach a spool gun to the end of where your regular MIG tip is.
I MIG welded that looks just like yours.
Yeah.
Oh, you do?
Yeah, but right now mine's set up for some of that, what is it, flux core stuff
Mm-hmm.
for steel. I put aluminum on it. I'm just saying it worked. I got it to run a bead just fine. You can't weld something like real thick like Doug said. It's aluminum. You know, it's hard to heat up, and you can't weld something real thick with it. But
Yeah, this is just
it's
1/8
like,
inch.
you can just do like square tubing and stuff with it. You know.
Yeah. Okay, I'll give it a try.
So anyway, sorry to interrupt.
That's
No,
fine.
thank you.
Okay, do I
That
get
was
this?
that was
Okay.
my share for the day.
Okay, Mike. Let's see, Ted. I don't see Ted. Did he drop? Oh, there he is. Ted, are you finished?
Oh, yeah, I was finished.
Okay. Well, I'm going to show a couple of things. First of all, I'll try to show it here. So this is the lens that was in the same Ozark
Oh,
Trails 200 lume flashlight, and you can see what it looks like.
Oh, yeah.
Okay.
Cool.
And so I put it on here so that I could adjust the height and see if I could replicate what Ray had done. And I found that yes, I could. But I did find that the height adjustment, I don't see how, Ray, with yours, maybe it's because you were used to 1 and I was using a 2 Pixie.
Oh, yeah.
The default height of cylinder that comes in it, this piece was not optimal.
Oh, okay.
Okay, I actually had to go. I had to adjust it around it. It was close, but it was, you could definitely not obstacle. You were not optimum.
Okay.
And just for the grins.
So by not optimal, did you mean it was out of focus?
Oh, I don't care about focus. I care about it picking up objects. But you're right. It is if it's really out of focus, it won't pick up the objects. So
Well, what you're saying is that depending upon the spacing, you had spillage over the edge and not, right?
Oh, well, okay. Give me a second here and I'll set it up and share it. Okay. Does anybody else have anything they want to talk about? And then go ahead while I'm setting this up.
In the meantime, while you're setting it up,
Okay.
I'll show you this thing, which I found.
Yeah. Oh, I just wanted to make a comment. I actually used like I think it was either 135 or a 160 degree wide angle lens on it, and it's the 12 millimeter barrel that you can screw out in the base of it. I don't know if you can see that well or not, but
Well, not probably right now because I was sharing a screen, Ray.
oh, okay.
So after I show it.
Okay.
Okay. So in the meantime, I found this. So it was sort of interesting that it's a little different than the normal Mars thing in the sense that they actually have so that all 6 wheels can turn. If you can see up there the little gears on the top. So I thought that was a little bit different design or one. And I think, let's click on that one. I think this is going to show how it does that.
So it has like a continuous rotation servo in each wheel or something?
Yeah. Okay, no, it didn't. Okay, not that one. See, this one that shows the actual turn. You know, you can see there where all the wheels turn. So I thought that was interesting, but you can see up there on the top how it looks. So, you know, so it can really turn on a dime, literally, which I thought was interesting. You can see there where the wheels turn independently. So I thought that was a little different than the norm.
What was their advantage of using the gears there versus just a direct?
Well, you can turn a lot sharper. So, you know,
Well,
and they're,
no, it looks like they're one-to-one gears.
oh, no, well, the gears probably are, but notice they had it so it could turn on a relatively small area.
Right, but what I'm asking is, what was the advantage of using gears since it looks like they're one-to-one as opposed to just putting the servos on the top?
Well, the servo on the top is just to change the direction. They have motors in the wheels actually to do the driving.
No, I understand what you're saying,
Okay.
but I'm talking about being able to turn the angles of the wheels, of why they use gears to turn the angles of the wheels versus just a direct.
I don't know
Okay.
the answer to that. Other than to me, it looks like it's much more a straight line. By doing
John, do
that.
they have a cutaway that shows us what's inside that arm where the servo is actually mounted?
That's the only picture I can see offhand for that. But you know, other than that, they have the parts.
Well, it's not clear to me where the servo actually is.
I think it's just right there,
Yeah, looks
right
like
on the arm, in the middle,
in the arm maybe.
right in the arm.
Yeah, that's what it looks like. But I'm thinking about, well, what's the advantage of the gears doing it instead of just sticking it on the top?
Stick it on top, looks more cool. I don't know the answer to that. I thought it was cool.
Yeah, it looks cool. I'm just wondering
You're right. Why
what
can't
the
it be on
advantage
top?
of having it geared like that versus, I mean, it looks like that adds complexity without necessarily having any advantage.
Well,
You gotta look cool though, you know.
well,
Yeah.
only thing I can think is that by being in
That's
the
got a
body,
cool
you get a little,
factor.
being in the body, you get a little more support walls. It's one thing I can think of. Where if you put it
Yeah,
on
maybe.
top, you would have to build more taller walls. Yeah. You know, in other words, they probably did it for, well, cool factor and, yeah, relatively low clearance. It's my thought for why they did that.
Yeah.
But the fact that they were independent all turned was the part that caught my eye. So, you know, it could change, you know, turn on a dime,
I
literally.
don't quite see where their wires are for their servos for their wheels.
Yeah, I don't either, because that's the one thing, you know, they didn't really show a good picture of building it. They have a picture of it, you know, running.
Looks like the arms are hollow. Maybe all the wires
Yeah,
go
that's probably what
to
it,
the arm.
Yeah.
I mean, that's the only picture that gives you a little hint of how, you know, it's put together. I mean,
yeah, it looks like, go back, John,
yeah.
go back to there, whoa. You see how it looks like yeah, there you can see it. They probably have. Now click your, the one that's got the box at the top so you can spin it. Okay, well,
Okay, so yeah, like there's the base with the motor, so you can tell where the motor basically goes right there.
I've noticed on some really good 3D print models they often do a great job of wire routing, because you can make channels, and it doesn't cost you anything. So so that's probably what they're doing there. Yeah.
So there's that one. And Doug, are you ready to?
Yeah,
demonstrate your thing?
I think so. All right, let me see if I can. Okay, guys, ready here?
Yep.
Okay. Enter. Now that I've been giving Michael all these instructions, let's make sure I can do it. Let's see. Can you see Piximon?
Yeah.
All right.
Yep.
So you can see there that it's picking up 3 cans.
Yep.
And you can move the cans and okay. It looks like one of the things that I gotta admit, my workshop lights are not very good, but I did notice that. Okay, so I'm gonna move this can towards the way, I think. So right now from the lens, I'm about 2 feet. All right, and that's probably, so it looks like 2.5 feet, maybe 3, depending on better lighting. It might be easier, but that seems to be the range of this. All right, now let me show what happens when I change the height. Okay.
Can you, whatever pixie you're using, can you change the lens on it? Can you make it?
No,
more
not on this one. Not on this
Oh,
one.
not on that one? Okay.
Yeah, and I gotta admit that, so you can see that, this would probably be where it took most of the field, but the lens, the distance that you can see goes away. You have to have at least the edges in view.
Yeah.
Everything's wiggling around because I'm letting gravity center it up. So that seems, so it looks like for this particular lens, maybe 2.5 foot circle around it. And I'm, right now, I can get a little ruler. I think I can do it.
Yeah, I think
it's probably about 4 inches. 4 inches from the tip of the lens to the camera lens.
Oh, okay. When I did mine, of course, I had much bigger. I had like maybe 2 feet by 18 inches for that. It's, I don't know what it is. It's that bright orange colored paper.
Yeah.
But I had them probably at least 10 feet apart from each other on either side of the lens, and I could see them with it. But I was using a wide angle. I think either I want to say 135 or 160 degree wide angle lens.
Okay.
And it filled the whole. Well, okay, it didn't fill it, I think 100%, but it caught. In other words, the reflector was in the full field of view of the camera.
Okay.
So you didn't have the kind of like the periphery.
Yeah.
Of the border.
Okay.
And the targets were much bigger, obviously. Something that's 18 inches by 24 inches is, you can get it much further away and still have it show up and see it. Cans, yeah, you're right. That may not work so well.
Well, no, well, actually, like I say, it's close. I think the field, on if you could get it to say 4 to 5 feet, so I mean, we're just talking about the lens that you found in a lantern. This is not a and I don't think it has to. I was thinking, what if you spray painted it with like chrome paint, not, otherwise 3D printed a lens shape and then coated it? Would it be sufficient to?
Yeah.
Because you don't really care. The only thing you really want to know is how far from the center it is, and in what direction it is. I could
What
see,
angle,
and that would be cool. So anyway,
Yeah.
so guys, Ray was not shooting bullshit. You can actually do this. So it's pretty amazing. I just wanted to share that since I took a look. But what's even more amazing is that you can almost do it with this other lens, which is the one that came the other end. But this is where the LED was, which is totally different shape. But I don't know if you can see it. There you go. You can see. I can pick it up with that too. So it was kind of cool. It was a lot of fun to play with. So that was one thing.
Hours of entertainment for just like $10. Actually, they went up. I looked at Walmart. They're like $12 now for that little lantern.
Oh, really?
It's like,
well.
Inflation has hit.
Yeah,
$12.
Okay, now for my real, the thing that I'm really excited about. If I can get it up here without breaking it.
Resistance or whatever it is.
This is the, I think it's called a 3018. Now, this one, the original ones that came out, this one is much more heavier built. And it has a lot of nice features, like it has emergency stops and in stops. Now, it has a little handheld thing in place. They did one thing I didn't like. They put it uses a micro SD card, which is kind of a pain.
Yeah.
But other than that, it works. I could run it, but you guys have probably seen this sort of stuff. Now this is the stock spindle, and it's way too small, and it'd be fine for engraving wood or cutting. You can cut acetate, acrylic with it, and that sort of stuff. But for aluminum, it would be it's not adequate. But I've got a much bigger spindle, which was part of an earlier aborted project that I'm going to mount on this. I need to make a new piece here, and that's similar to the one that they actually show in their YouTube video. Not the YouTube video that I discussed before everybody got in, probably, of a brother-sister team that's got a small YouTube channel that she's doing a great job of. So,
Doug, put your hand back in there. That was useful scale for me.
Okay. All right. So, if you
reach over there and grab the spindle.
The spindle?
Yeah.
Okay.
Okay, so it's about that big.
Yeah. This is a 75 watt spindle. The one I'm going to use is a 600 watt. If you guys will hold on just a second, this will just take a second. I'll go get it.
Yeah, that looks a lot bigger than a 3018. Did you get like a bed extension for it or something? No, figures you just left.
Elvis has left the building.
It probably is bigger. It's probably why it sits by Travis, my thought. Because, they come in like 3 sizes.
6 by 12 inches?
Yeah.
Oh, I think it's 3018 is bigger than that to start with, though, isn't it?
They came in. They were relatively small to begin with, and they've grown up over time. So, in other words, I have the small one. If you remember that, and actually Dave had that small one.
So
that's like a Sherline size machine.
David, for comparison, you can see the difference here. Can you? So here's the new one.
Yes.
That's the old one.
Yeah.
Right, and this is a little bigger than the one that she used in her particular video. She used a 500 watt, but I have already purchased this from for a previous project, so I'm going to try and put it in. This is a 600 watt one. So anyway,
Well, that will be much better.
I'll see if I can find her channel and put a
So how
link to
big
it
is
so
the
that
bed,
you guys
Doug?
can see it.
So
It's
you
really
don't
interesting.
offer-
When she bought hers, it was $219. When I bought mine, it was $232. So inflation had brought it up a couple hundred.
How big is the bed? Is it
It's about the size of a piece of paper.
so 10 by 12ish?
Really?
Yeah. Okay. Here. So here's a piece of paper.
Okay, which is basically 9.5 by 11, if I remember right.
8.5.
8.5. Okay.
Yeah.
Let's see, what did I do with the pixie? Oh, here it is. And I'm going to present this again. Okay, so here you can see the paper. So that's it pushed up against the back wall. So you got probably a page and a half one direction, but you don't have much in the other.
Right.
So I want, like I say, if it's truly a 30 by 18, it's supposed to be 30 centimeters by 18 centimeters.
Right. So yeah, 30 is just about a foot, little under a foot, and
yeah, you know, looking at it, it looks a little bigger when I put that piece of paper in there, but I guess that's only 10. Well, it looks to me like it's about. Oh, and again, I don't know exactly how much of that table is usable space. I would
Yeah, is that usable space versus the actual space of the table?
Okay, so let's see how far. Let's see where it is. Okay, here.
Yeah, if it says 30 by 18, that's basically about 12 inches by 7 inches.
yeah,
So,
right.
so you can go to the front for sure, but obviously in the back side you've got this amount of space that you can't use because it's gonna. Well, let's see, it's slanted back. So let's see. It looks to me like it's got more than 12 inches, but we'll see.
So Doug, that's all the way back?
It's not back yet. That's what it was all the way forward before. I'm just trying to see how far.
Well, let's see, does that mean when you replace the spindle with the new larger one, that the centers of the spindle have to line up?
Mine won't. So you'll end up with. But you when you turn it on, you determine where 0 is. Okay,
Gotcha.
where the origin is. So that's not a problem. It's not a fixed origin. They do have limit switches, but I think the limit switches are just, if you had for example, if you had a long bit, which you shouldn't have, but if you did, you could actually overcome the. Okay, it looks like I'm getting close. Yeah, it looks like with a stock spindle, there it is. You see, it didn't quite go all the way to the back. Okay, so they're 12, even though the bed looks like it's about 17 inches, it's probably 12 inches. I'm just going to assume they got it right. So anyway, this is my new toy, and we'll see how it goes. Like I say, I'm hoping it won't be a monster to you know, this might be one of those things that after you upgrade the spindle and you do everything, you could have bought another one for straight up for that price, you know. We'll find out. But I do got to admit, I like this size. It's a little small for some things that I could imagine you'd want to make, but for probably our small robots, I'm hoping this will mean more metal parts for me. We'll see.
Yeah.
12 by 7 seems huge.
Yeah, but I don't think, I don't know. I think it's more like 9 by 12.
Yeah, I agree. That's probably about the size you're going to get out of it.
Yeah.
Yeah, that looks about the size of ours, isn't it?
No, well, the one I have and you have, Dave, is a little smaller in the depth wise.
Yeah.
He has more depth.
Mhm.
And
Oh,
actually a little bit more width too.
The rigidity on this one, okay, if you go and look at a normal 3018, the, gosh, guys.
Yeah, but it did look like it was more absurdly well built. So you're right about the ridge fatter.
It's if you look at like for example, if you buy the stock, the ones that are normally sold, these bars and the bars underneath the Y are 8 millimeters, and here they're 12. So it's been beefed up quite a bit. Plus, you know, okay, you know, I can see some flex, you know, if I really push down on it, but that's, for this type of machine, I think that's probably the best I've seen. They're not, you know, they're not like a full milling machine. They're not, or they're not like one that you pay $2,000 for either. So, you know, we're talking $200 here, $230, and like I say, if you want to go metal, probably another 100.
Yeah, but for light plastic, light wood,
Yeah.
good for stuff like that.
Mm-hmm.
Doug, could you put the link in the chat?
Not yet. I'm going to. Who else wants to go next? Okay, Pat, you go, and I'll go find that link.
Okay, I just had something small I found online. I've been looking into, as everybody knows, with my chain link fence problem for RoboColumbus, looking at ways, what can you do with a Raspberry Pi and a camera, either OpenCV or a little, one of the little machine vision cameras that are available out there. And I came across this site the other day. Description product. Share my screen, and so I came across, maybe I'll go to the other one, it's easier. FOMO, faster objects, more objects. So it's like YOLO, only another acronym. And basically,
Do that for
they're detecting multiple objects fairly quickly with a fairly small, from what I understand, training model. I haven't gone too deep into it, but it might have a little bit of promise for what's going on.
Yeah.
It goes into a little bit of how it works. I haven't gone in real deep into it. Here they're detecting, it looks like screws. And so they've got, I don't know what it is, a matrix set up where they're going in and looking at it. And then they got a thing that says, well, if you're trying to classify small objects, it could have, shouldn't be too close together. They did have, I think on this one, looks like they're detecting bees. So I sort of thought, well, maybe you could do a little bit better than what they're saying in the other article. Goes through the limitations in the video again. So I'll put the link into this, and if somebody's interested, they can read up a little bit more on it. I don't know if how much I'll have time to go over all of this.
You could have a FOMO, YOMO, or not see FOMO, YOLO.
Yeah. So like I say, I'm trying to detect fences, in particular chain link fence and foliage, which I think is going to be the issue with an outdoor bot. And I don't know. So I thought that maybe that could be an option. Just another uphill learning battle.
If you can detect bees, maybe it could spread honey on the chain link fence and detect the bees. You know, you're all set. You know.
Just something that came across while I was looking up for object detection.
Good.
Well, you know what John demonstrated with his little quick demo that he made a couple of weeks ago was that the fence looks different from different angles. Looks so that a simple algorithm that's just trying to look for a certain geometry would get complicated really fast, especially some of those low oblique angles where it looks like spirals. You know, chain link looks like spirals winding around each other. It doesn't look at all like a chain link fence. It seems like, however, that might be something that would be spot on for machine learning, because all you're doing is saying all these different pictures are the same thing. You know, if it looks like any of this, it's a fence, and that might be a real useful approach. I don't know anything about that tiny machine learning, the tiny ML.
Yeah, I've looked into it a little bit, but it's a little convoluted that you have to do the learning, and some of it is online. Like you have to assemble all your pictures, you have to go in and label all of your pictures, put a bounding box around the objects.
That's why a tiny and machine learning don't really go together.
So that's where I was looking at this one, and at least the footprint. They're saying the footprint in memory is about 200K. So it's you know, it might be something that's doable on a Raspberry Pi or one of these like little OpenMV. I think they mentioned using it on OpenMV cameras.
Well, also your use case, you don't want to have false negatives, but false positives are not really a problem. If you dodge around a shadow on the ground because it looks like a chain link fence, that's probably okay. You know, but
I would agree.
You don't want to run into a real chain link fence.
I think I'm going to try the depth map idea first and see how that works. The weather's turning a little nicer here. All the snow's gone. I think I'll get my robot outside on the grass, snap a few pictures by the fence, and then see what I can do with a depth map and a checkerboard pattern and getting that all calibrated.
Cool.
So if I have anything before I hit the road in May, I'll post it on there.
Okay. Now, when you say May, you mean next week, right?
No, when I say May, I'm talking about the American long weekend. So we have the Canadian long weekend the weekend before, so probably Wednesday, Thursday, I'm hitting the road. I'll be gone for 7 weeks. I've got
a pretty long weekend.
Yeah, it's a long weekend. I've got 2 sons and a grandson that I haven't seen in over 2 years. So we're heading west, latch onto the trailer and head west.
Cool.
Take a robot with you.
I'm thinking about it. So either it'll definitely be Arduino, Raspberry Pi, something is coming with me. So robot would be cool if I could do it and not get it destroyed on the way there.
Or by the grandchildren, maybe.
Yeah, well that's the other thing. They're not toys. They're for big boys.
Doug, I want to know what you plan to do with all those alarm clocks.
I don't know. Probably just, like, some of them I really like. You know, you get kind of attached to them after a while. The big thing is not to get any more alarm clocks. I got plenty, you know. But it's really interesting when you got several to choose from. You develop favorites. But I have one. I ran across one that's an old peg leg one from probably somewhere between 1910 and 1920, and I ended up with it, or maybe 1910 to 1930, and I've got it apart, and I'm hoping to be able to put it back, clean it up and get it running again and back
And so you
working.
become
Peg
fond
leg?
of them?
Hmm?
You become fond of them?
Yeah, some of them.
Have you named any of them?
No, I don't go that far.
There's hope then. There's still
Yeah.
hope.
Yeah.
Do you want us to send you our broken clocks so that you can fix them?
Yeah. Like I say, if you had one that you were just going to chunk in the Goodwill, I wouldn't mind having it. But
So how much of them do you have to wire up, or are they battery powered electric
no,
versions?
no electric, no battery power.
Strictly spring driven.
Yeah,
John, you have to remember what a battery was in 1910.
yeah.
Well, that's
Yeah.
true.
Let me. I started off. There was an owl clock that was sentimental to my wife. When she was a little girl, an old lady gave it to her for how you sometimes give a little kid something. Well, she gave him this owl clock, and it never really worked. Okay. But it was just it's very pretty. It turns out there's actually one for sale that works on eBay right now for $1,600.
Well, there you go.
Yeah. So, but anyway, my thought was I'd try to get this to work for her. Well, it turns out the clock's in not bad shape. But the real feature of this was it had two eyes that would go boop 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 with the clock. And the mechanism and everything is actually missing. So but there's plenty of these clocks, pictures of this clock all over the internet. So I'm hoping, and I actually had Rick Swan over here for a weekend. He came down and visited with me, and he's an old club member. For those who don't know Rick. He's also was the author of, what was it? Robot C.
Robot C.
Yeah. So anyway, he's pretty sharp, and between the two of us, we figured out how the eyes worked. Even though we only have like the two ends of it, and the whole train in between is missing. But it turns out it wasn't very hard. But I think I could get the eyes to work again. So that's my ultimate goal. That's why I got involved in it. If I can get that clock to work, everything else is. But I didn't want to start off on that clock because
That's like that. What is it? The Etheria mechanism
yeah,
that you had to figure out, deduce how it works by
Yeah.
looking at the input and the output. Yeah.
yeah. It was really unusual. Well, I'm not going to go into clocks, but I will say that was the driving force for trying to get into this. And like I said, I didn't want it to be the first one because I'm going to tell you what, my first one, I took a really nice clock and turned it into a pile of scrap because it's a lot harder than you think it is. Yeah, so anyway.
Oh, cool.
Okay.
The professor who originally hired me at SMU is a seismologist and fascinated by clocks because time is a big part of seismology. Time's also a big part of navigation.
Mhm.
And so the whole way that we have zeroed in on increasingly accurate clocks over the centuries was something he knew a lot about. And he told me, this is, I'm just rambling totally off topic here. There's nothing to do with the robots. The clocks they used for doing the seismic measuring, the atomic clocks, were good enough that they could take two of them in one of his classes and synchronize them and then take one of them, leave one in the classroom, take the other one up to the fourth floor in the elevator, and you can watch them drift apart because one is higher in the gravity well than the other.
Yeah.
He said the new clocks that were getting ready to come out, and this was 4 or 5 years ago, were accurate enough that you could see the difference between one sitting on the floor and one sitting on the table. They would drift apart.
Well,
Yeah, time ain't what it used to be.
no. Well, these alarm clocks, if you get them with plus or minus 2 minutes of each other, you're golden. I mean,
Well, what I think I hear ticking is a conglomeration of ticks. It's not a clean tick, 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 tick.
yeah,
It's a rick, 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 like there's a bunch of clocks running.
yeah. There's like 5. That's what you're hearing. Yeah.
I feel like I'm on an episode of 60 Minutes or something.
Exactly.
Let's see. There was something.
Did you see in the news that possibly time doesn't exist?
Oh God.
Oh gosh.
Oh, that's such a relief.
Thank you.
And also, time is going backwards too.
In the quantum world, they're trying to
Yeah.
they're trying to prove that time doesn't exist.
Mm.
Hmm.
So David, if that's the case, you know, are heads aging slower than our feet? Because, you know, our feet when we stand up are
I guess so. Maybe that's why we lay down when we sleep.
maybe, yeah. I didn't think about that. Or
Yeah,
Yeah,
they're one checked up with the other.
Ted Myers and other guys, you know, they're what, Mile High City, you know, are they aging less than we are because time is slower up there?
Yes, but they're also thinking slower.
Yeah, and it means I have less time to work on the contest.
Oh,
That's right. That's right. You know, while as we pointed out, Murray has an extra day to work on the contest compared to us.
mm-hmm.
Are you sure it's an extra day, or he has 1 day less? Because it's
One
already
day less, I
tomorrow
thought.
then.
Yeah.
No, he has an extra day. So
Well, he's
like,
a day ahead, right?
yeah, so like when it's 6 in the Saturday evening for us, it's Sunday afternoon for him.
Yeah, but that makes it worse for him because if the contest's on Saturday and
Oh, that makes me feel better.
So, Doug, speaking of eyes, there's movement of how they did it with the cat clock. If you remember the cat
Yeah.
clock,
This one is really different. That's
Give you
kind
an
of an
idea
that's
how you can do it.
that's a pendulum. That's a pendulum
Right,
clock.
very simple back and forth.
And is the other end of that waggling his tail?
Yeah, and the tail is at the bottom and the eyes are on the top there, but yeah. Because that's the type of clock I remember in the kitchen at grandparents,
Oh
where they
yeah.
had the eyes moving on the cat.
Yeah. Well, I have a question. I have a roboty question I want to ask. All right.
They show the front.
Okay.
Yeah, in their case,
If,
they show the back, but
We have
yeah.
when we do.
But yeah, so yeah, that's a pretty straight concept. But yeah, they were neat.
Yeah.
So,
Okay, I have a roboty question to ask. All right. Okay, and this is something that occurred to me as I was going to sleep, and I'm not even sure it's pertinent. All right. We take encoders and we use them to tell where we are. All right. But every time we take a measurement, all we know is that the last encoder tick was whatever it was. All right, and we know it hasn't quite got to the next encoder tick. So whatever the distance between two encoder ticks, you have an uncertainty to where you actually are. All right, now, is this something that is cumulative, or is it when you take the next measurement, you've already taken into account that extra tick? Or is this something where you could say on average they're going to be half a, if you looked at it, if you just said, okay, it's going to keep happening, you would find that there'd be a distribution, and the distribution would be Gaussian, and it would be half a tick. It'd be between half the distance between the tick would be the most common value.
Well, if you take and let it accumulate, then it should not be a cumulative error. That is, if it keeps going around, it'll go past that spot again. So that if you are accumulating it as you go, you won't have an error. You'll just have plus or minus, that one amount, but not accumulative of those amounts.
I think you're talking about predicting what the next, what it would be in between ticks. So if your clock cycle is way faster than your tick cycle, could you predict when you would expect the next one to come along? Was that the question, Doug?
No, here was what I was thinking. I was saying, okay, so you have a certain uncertainty of your actual location. You know you've gone farther than that last tick, but you haven't gone farther, and let's say between two ticks you travel 5 millimeters, or let's say 10 millimeters just to make it. That I'm sure with our high encoder counts we don't do that, but just let's say it was 10 millimeters. All right. The question I had, would this be something that you could put a one-dimensional Kalman filter on, and or a Bayes filter, and actually get a more accurate cumulative, or does it really matter because, like, the next time, otherwise it's not cumulative. You don't lose half of.
Cumulative.
It is not cumulative.
Not cumulative.
Okay, all right. So
and you can't know the future, right? So the only way you could sort of, maybe you weren't asking about prediction, but
no.
The only way you predict it, which is partly what you do with a Kalman filter, is with the model, is you gotta have some sort of, you gotta have a model that sort of makes some assumptions about what's happening. So if you're moving at a continuous rate, and you have some other way to determine that than your encoder count, then you could sort of predict what your uncertainty is and correct for it. But if you're not, if you don't know what your movement rate is, there's no way to tell when that next tick's going to drop.
Doug, I would agree with that and only take it one step more general in that basically anytime you quantize an analog signal, which is what we're talking about here, right? And then there's that error between sample points, and there's math to deal with that. That is, you have to be sure that you're sampling it above the Nyquist frequency for the range of changes that you're likely to see in that signal. And if you are, you can safely say the samples represent the signle pretty accurately.
Yeah. I
So
knew
the
that.
only thing I have to add to that is there's two ways to measure encoders. You could take a fixed time period and take the number of ticks per time period, or you could measure how much time between the last encoder tick.
Yeah, I know.
Yeah. You don't know if you've stopped or not, right? If you stopped, then all bets are off.
Yeah.
You could be very quickly deaccelerating.
Yeah, that's the problem that Paul's trying to solve with his. He's come up with a solution that seems to work for him. He's using the second method, Ted, because his wheel only. I don't know why he just doesn't upgrade his encoders. He has like 10 ticks per revolution. It's like. Wow.
Yeah, I've tried to talk him into that he could add high-resolution optical encoders to the back end of his motors, and all these software gyrations he's having to go through would suddenly go away.
Yeah, I mean, I'm a firm believer, and I think you are too, David, is that if you can fix it in hardware, do it, because that just makes everything else simple.
I go a step further than that. If you could fix it in hardware and buy the solution from somebody else.
Well, but I the only problem with that is this is a hobby, so you do some of that, you take on some of that pain.
But we just established that time is an illusion, and we have resources there.
Well, time's running backwards, so you have all the time in the world, right?
Yeah.
Yeah, but as I understand the theory, Harold, we can't tell. if it was running forward or backward, it would look the same to us.
Oh, so we're in the Bizarro world, and there's some alternate universe on the other side of that's actually going forward, and we're the bizarre ones. Got it.
And that's the one where the unicorns are. and the artificially intelligent robots.
Is that the unicorns that fart cotton candy? That's what I want to know.
Probably psychotropic drugs were involved.
Then time gets really mixed up, right?
Well, I ran into that when I know I've told this before. When I first started working on the balancing robot, I got a gyroscope and I built my own little. Actually, before that, I just used a real low friction potentiometer. First to balance a ball up on a stick, and then mounted underneath the robot to give me the angle of the robot to the floor. And I spent about 1.5 years trying to come up with an appropriate angle sensor, which is only half of the problem. If you had a perfect angle sensor, I bet 9 out of 10 robot builders still couldn't get their robot to balance. That's the hard part, is the balance algorithm. But after I spent about 1.5 years on that, I thought, this is not where I want to spend my time. This is not, I want to work on robots. And in the last 1.5 years, I could have bought a solution. There are people in this world, hard as it may be to believe, who live and eat and sleep Kalman filters. And that's their thing. And just pay them.
You know, I'm
That's
glad
what I ended up
I'll let
doing.
them have all that. I'll let them have every last bit of that fun. I will not take that fun away from them.
Yep.
I'm having a hard time remembering. If I showed you the latest iRobot Create version 3, they're
Yes.
dropping in June.
I think you mentioned it before. I
Yeah,
don't think you
you
Yeah, I
did.
think I mentioned it before. Yeah.
Oh, yeah, you did.
Did you get yours, Harold?
No,
Did-
no, I haven't ordered it yet, but
Okay.
And,
No, you
think,
did
yeah.
go over it. Yeah.
yeah, I've been preaching that to a whole bunch of people, and I can't remember who I've told when I've told them, and
Mm-hmm.
that kind of stuff.
So I was interested by that discussion of the iRobot Create, and I kind of heard that the prior versions, 1 and 2, didn't exactly perform up to snuff. Has anybody had any experience with those?
I have a 1. So, the original iRobot was probably about an Arduino, had an Arduino type, actually a 128, so it was a small, not even an Arduino controller, and you essentially have on the robot, you can ask it for certain values and it will return them to you. I think you can also push, huh?
Are we talking iRobot or iRobot Create? The vacuum or the?
iRobot Create.
Okay.
It's a educational version of it, you know, and but it was made up of mostly that's Roomba.
It's like the vacuum.
Yeah, it's got a lot of vacuum parts in it. So the part I didn't like was the battery, because
Why?
well, it was metal nickel hydride, and I didn't use it. I mean, if you used it like in a classroom where you use it every day and you kept it charged up and everything, for me it was always, it was never, the battery was, I hardly ever used it, and then when I finally did use it, it would go bad, you know what I mean? So it just was hard to keep a good battery in it. That was what I didn't like about it. Now, if you didn't want to use their charging circuits, you could have put a lithium battery, but you can't charge them. You can't use the iCreate charging station in that situation. We actually have in the club, if you ever want to try one, we have a TurtleBot, which was a Ross robot that used that base. We have it down at the Makerspace.
Interesting.
If
I
you
have
want
to
to
admit my interest is because I'm lazy, sort of like what David Anderson was saying a minute ago. If I can get the base with ROS installed and a charger I can pull up to for $300, that's chicken feed to me.
Oh,
Get
well,
that done, and then I can get to the programming part.
okay, here's the one thing that kind of scared me about the 3. Now, I'm not saying, take this with a grain of salt, because they're not even released yet, okay?
Right.
So,
it's new.
but they don't have encoders in them. They use,
3 has encoders.
huh?
The 3 says it has encoders.
No, I don't think so. I think
Oh, yeah, it
he
does.
uses, what do you call it? With a surface,
Using
Like a
flow.
mouth sensor.
Using a flow sensor.
yeah, it's using a flow
Optical
sensor.
flow.
It's
Yeah,
using optical flow instead of encoders, is what I understood.
Mhm.
All right.
At least that's what the documents does say. It has an optical flow. I don't know that. I don't remember seeing encoders. Of course, it's been
In-
2 days.
Yeah, in the one, it had the same encoders as the vacuum cleaner, and they were not perfect. Let me put it that way. They had some problems.
You're saying the
If you go back, if you're willing to look for it, Paul Brochure, the person Paul, he actually had this a Roomba robot that he used a lot, and you can see the videos of him competing, and he never, in my opinion, it never lived up into its potential. But I'll tell you where it really shines. Okay, so you got a bunch of 2nd grade kids or 1st grade kids, and you're doing a robot demonstration. So what you do is you have like one of these, lunch tables, white lunch tables, and you have it set up, and you just turn on the Roomba and you stick it on there, and you just go on with your presentation, and don't even look at it, and it's coming over to the edge and stopping and rotating, go to
With
the other
sensors,
edge and
yeah.
turn it, because it's got drop sensors on it, and the kids they're watching it like cats, very, very cool. If you handle it nonchalantly, the kids just eat it up.
They're probably just waiting for the thing to go over the edge.
Right? Yeah.
But not yet. Oh.
Well, that may work with kids, but Doug, when I very first introduced myself to the DPRG, which was over at the old Infomart, I walked up to the front when they invited me, and I turned on SR04 and put it down on the floor and began talking, and it blew away that whole group of grown-ups.
Yeah.
Somebody on the front row said, and this is what led to our gold stars directly, somebody on the front row said, he can turn his on.
Yeah.
That's the part I want. I want to get the darn platform working so that I can get to the coding. I've got all these coding ideas. I'm getting old. I want to get them coded before I'm too old.
I know
You know,
what you
Doug,
mean.
people have been looking at this for years. I mean, as long as I have been involved in robotics, there's been this idea that if we could just come up with one platform and help people get over this problem of building and get right to the software, and it's never really happened. We in the group have done it and came out with a usable robot.
3 times that I know
Three
of.
times, says Doug.
Yeah, 3 times.
I think part of the problem is that with robotics, the actual hardware design is really part of the solution to the problem you're trying to solve. So it's real hard to come up with a generic, general purpose platform that appeals to everybody. Everybody says they have their own way of doing it.
It feels is the important part of that phrase.
Yeah.
Exactly.
Everybody's got their own specifics they want.
Yeah, their
I
price
want my
point
little
too.
roam around the house robot, and I wanted to do pretty much what that Roomba does. I just want to not have to build all that. Did you have?
Well,
to-
and there are real good builders in other clubs whose image of a robot is something that looks humanoid and that interacts with people by talking. But they don't care that much about what we think of as navigation and things like that. They're really looking for a kind of a animatronic. It's a different concept of what a robot is, and I'm not, it's different, and that's all you can really say.
See, I want my robot to talk, so I want to get into that part of the program.
So
I just want it to be able to go to X, Y when I tell it to. I'm having trouble with that part.
yeah.
But
So I don't know that there is, people always point out to what's
Getting
happening in the computer industry and how we have kind of standardized hardware that lets people jump right in at the software level. And they'd like that sort of thing for robotics, but I just don't see that it has happened. And I don't see really a good way to make that.
Yeah, I don't think it's possible to make a standard, but there certainly are platforms that can be a good base to start from. It's okay.
And there's lots of them out there.
Yeah.
As I said, everybody and his dog has tried to come up with the one robot kit that everybody will use.
The thing that made me happy about this one is it had its own self-charging platform, which is one of our requirements for the robot I have in mind. I want it to stay on 24/7 and just go over to its charging platform and recharge while it's watching around, and then take off again when it's ready.
well, Doug, I think the iCreate 3, I think is lithium ion, so it, that probably, if you that I think that Harold,
Yes.
is the iCreate 3 lithium ion battery?
I think that it is, and I think that from what I read, of course, it hadn't been released, so we don't know.
Yeah.
That it knows how to go back to its base station already.
Okay.
At least that's
Well,
the
the real-
impression I got from our reading. It knew how to go
Real-
state charger set, right? So it knew how to do that,
Yeah.
which I think would be a bonus cool thing, right? To be able to utilize that and not have to write that problem, fix that, solve that particular problem.
So battery types that turn ion, encoders too. Am I showing that on my screen?
Yeah.
The
Okay. So
the thing that's got me a little bit worried on this is because when I say worried, it's because what Doug had said before on this thing is that you could ask it questions and it would give you answers. You're not really programming the thing. You're asking for information. What's its sensors? They say it's a ROS2 node, which that implies that I can ask it information. It'll publish stuff, and it's more than likely a service, so that I could send something to it and it would publish answers back to me. Not really actually coding the thing on the robot itself to do a new behavior.
Right.
So
you have to learn ROS and all of that stuff that you and Chris have been worried about.
Well, maybe you do, maybe you don't. Maybe they've got some libraries and some environments to help you with that kind of thing to get started, and at least to get started. If you're going to do very much, you're going to need to know how the raw stuff works. But maybe I don't know. Maybe they've got some tutorial things set up and some Docker files and a few other things to help you jumpstart right into the middle of all that.
Yeah. Well, we'll see. I may get one if I have time to work on it again. I'm still real busy in my other projects right now.
yeah. Hey,
Well,
Doug.
Harold, you remember a couple of years ago we had a presentation by a guy, I believe he was a Microsoft Ross.
Yeah, Lou, I'm supposed to have a phone call with him this coming Friday.
Okay. Well, if you remember his talk, part of his appeal for Ross too was he said this is the way all beginners are gonna make robots in the future. And I've not found that to have come to manifestation.
Well, I will tell you, we're making some progress on my Zemo robot here with doing some of the, well, I'm going to call it Ackerman turning, but it's the thing we're talking about with angles of wheels inside, outside, and that sort of deal. And we made some pretty good progress in making it going, and I've got it back to doing what almost the original ExoMi was doing, but it's all under ROS 2 and it's all coded by me. And
you need to give us a demo. Maybe that would be a monthly talk.
Maybe, yeah. I'll be happy to do that. In fact, I think it's sitting over there now because I've got it moved out of the way because I'm prepping to do some stuff for tomorrow night. But hopefully by this Friday we'll have that working, and then I'm trying to figure out, and you guys are right. I was thinking I needed to do a separate Ackerman style turning, driving thing, and spin mode and crab mode. And after I've been doing some working with it, I think all I really need to do is the Ackerman style turn mode with some special cases, and then we have the crab mode to keep the heading correct. So, because what I'm thinking is, as I'm turning and the radius gets so tight that the inside middle wheel just needs to stop and let you kind of spin around it. And then once that radius gets inside of the robot proper, inside the wheels, I just say go into spin mode and set all the right stuff. And now you're, when you're pressing forward or backwards, you're spinning left and right until you ease up on the turn.
Cool.
Ease up on that thing. I think that's how I'm going to end up coding that. You know.
So,
I hope that's probably going to happen. Part of that's going to happen Friday night. So we're easing up on all this kind of stuff, and I'm about to actually do stuff I want to do, which is figure out navigation and GPSing and IMUs and all the other kind of stuff that's going on.
That's what Doug was complaining about.
Yeah.
Wanting to do the real robot part.
Yeah, want to do the real robot stuff. I mean, this is all fun because I'm learning tons of stuff. We're figuring tons of stuff out, and it's going to be something we're going to bang our heads in before. You know, we need to know some of this underlying stuff so when things go wrong,
well,
you know what you're doing. But
I have to say, one of the things that has struck me is that it reminds me there was an old sketch, for those of you who can remember the Smothers Brothers show, where they came out.
Not old enough.
You got to take it. No, I ain't got to take it. I don't want to take it. You take it. No, you know, if I say take it, you got to.
So they come out.
Tagged all of us.
They have just an acoustic bass and an acoustic guitar, and they start singing one of their folk songs, and then Tommy stops them and says that they need to get modern and upgrade. They pull back the curtain, and they've got like all these stacks of Marshall amplifiers and electric instruments and everything, and so there's a big funny scene. But finally, they don all that heavy gear, and they start playing, and they sound exactly the same. Exactly the same. Okay, so this is what strikes me. I see my colleagues and people in other groups building these incredibly complex ROS operating systems, and when they finally get it all working, they have a robot that can say, stay on a table and not fall off. I mean, the things they accomplish look like the sorts of stuff you do with the most rudimentary basic stamp robot from 20 years ago. So, as I say, they got all this extra equipment. They sound exactly the same. I'm still waiting for somebody to say, look at my ROS robot doing something that can't be done any other way. I still haven't seen that.
I don't know that you'll ever see that. I don't know that you'll ever see that, but maybe there's some interesting ways to do that.
Well,
right?
When your friend was here after he finished his talk, I asked him specifically, do you have any videos of robots doing incredible things that would justify all of this overhead? And he said, well, that's a very good question. Those of you from the corporate sphere know what that means.
Means no, yeah. Don't have that.
Hey, Doug, one thought about one nice thing if you get the Create 3 that's your software becomes independent of the robot. The robot is completely a fixed base. The problem, the other side of it is it might be, otherwise the base is whatever you get with the iCreate. Otherwise if you put an arm on it, that's something else. You put a bumper on it, well, it's got a bumper, but if you put something else on it, it's going to be different. But the basic functionality that's there, it doesn't care about how you handle those messages. Just like, that's why it's ROS, but you don't have to have ROS to do that. You can do it out. It's just ROS is one way of doing it.
Well, as I'm building this stuff, I'm gonna plus one you. I'm gonna say yes and on that, because as I'm building this thing and doing it, I'm envisioning what I'm building and how I'm doing it, and thinking to myself, well, if I had to take this off of the rover, off the 6-wheel rover, put it on my donkey car over here, I've got a configuration in there that tells me how many servos and what those servos are and their names. It'll take me a little while to configure it all, But as far as rewriting a bunch of the code for driving of servos and driving these other things and watching for IMUs, that's exactly the same code on every one of these robots. It's just how I utilize that information in a half dozen of the nodes that I have to write specifically for whatever the robot's purpose is going to be. So it's it does lend itself to some modularity, like you were talking about there, Mr. Video. It really does, and I can see some advantages there. It just there's just a lot to learn. That's kind of where I'm at. And I am learning. People on my Twitch stream are learning too, and they're actually someone's like, hey, well, why don't you do this? Oh, I can't do that. And they're helping me out and that kind of stuff. It's kind of fun sometimes. So yeah, is Ross still here? Ross comes by and sees me on a very often, and he looks at me banging my head into the brick wall trying to figure this stuff out. And I think he laughs at me sometimes, but that's okay. It's absolutely okay.
Mm-hmm.
Well, picking up a little bit on Dave's point, I just got back from a week of judging FTC at the World Championship, and I saw 160 teams from all around the world, and
cool.
These kids are doing some amazing things, and it doesn't really matter they're all stuck on the same platform, so you're judging them against sort of what they're doing differently from other teams, and they're making incredible leaps in sort of practical robotics experience, and it really doesn't matter what the underlying platform is. If you just sort of accept it and start moving forward, and they at least have the structure of a common game to sort of judge against each other. But there are a lot of unique solutions out there, and it's just amazing the rate at which they're going. So sometimes you got to just sort of suck it up, choose a platform, and start moving forward.
Yeah. Drive a stake. Put a stake in the ground and start going off of that regardless, right?
60 teams.
160 teams, and that was just first tech challenge. That's the one that my team competes in. There's also FRC, which is the larger robots. There's fewer teams, but much bigger, number of students per team. And then there's First Lego League, which is all of the, Lego Mindstorms type robots, and that's way bigger. There's like 160,000 of those students competing every year. It's just crazy.
It is crazy, and if you've never been to one of those things, as soon as we can go into in person again and they start having them around town, I will be the first one to step up and go, hey, if there's an FRC event or any of those events that you can go, even if you don't know any of them, nobody there, if you can go in there and see that, the energy and the sense of camaraderie and everybody helping everybody in that room is infectious. It truly is. It's really
Kareem.
They all started up in person again. So I was I got the cough to prove it. I was around a lot of students. It was the highest density thing I've done in 3 years.
Where was this?
Huh?
Where?
It was in Houston.
Well, there's your cough right there.
Yeah, exactly. At least it's not COVID. I tested myself this morning, but I did pick up something right there.
No offense to people who live in Houston, but my only use of Houston is to go through it, to go down to Galveston to get on a cruise ship. That's all I got.
Hey Kareem, if I heard that right, I think you have another judge volunteer.
That's what I heard for sure.
Yeah. Oh no, I need to be careful around you folks. Oh my word.
Well, Kareem, how many of those did you actually have to judge?
I had so there were 64 judges because of the number of teams that we had to deal with. So the first round is a day of interviews where they come to the judging rooms, and I had 8 in my panel, and then we break up into different awards categories, and I got assigned the control award. So that's all about software basically. And so this is where we start interviewing in the pits. They have a 2-page submission that they have to give us to indicate what it is that they had unique. Plus, we get recommendations from the other panel judges that had the interview, and so then we had to sort of winnow that down into a short list, and we visited probably the top 20 teams instructional software across the entire event.
How long did this take?
It took 4 days. It's a very in-depth kind of thing. Now the judging was finished by the end of the 3rd day. So the last day was just competition and awards. So we sort of made our decisions by the end of the 3rd day.
Well, that's just excellent, Kareem. I'm so glad you do that. You know, it makes me be proud of the club without actually having to have any effort myself.
No, you're not lifting a finger a word. I know people. Yeah, no, it's a good feeling to. I mean, it's not like I'm going there to be all judgy on them. It's because I want to sort of help them improve the state of what it is that what they're doing. They need to be able to tell that story to somebody, and I think that's there's a lot of value in that.
Absolutely.
Yeah, I'll tell you. There's another event that happened in February, and that was the Dallas Regional Science Fair competition that goes on. It's sponsored by it's organized by SMU, and it's held generally since they started meeting back in person over at the one of the buildings in Fair Park where all the cars or stuff usually are.
Yeah,
those I will tell you, that's another inspiring thing too, because they have middle schoolers and high schoolers, and you can tell that some of these people in the science fair are going to grow up to be car salesmen, but we need those too. And there's other people that are actually really impassioned in what they're doing and really get into the science and really think they're and not just they think they're going to make at least a little impact with some of them. Some of them are doing it because they were told to do it, but some of them you can tell that they think they're on to something here, and they really get into it, and that's just exciting to see. And I love to see that stuff. Some of them I hate to tell you, like, that's not going anywhere, but I appreciate. I don't tell them that because you're supposed to be building them up, but and I do it. But I love to see the passion. I love to see the try and the trying to find a new way to do an old thing is always a fun stuff. Always some fun stuff and comes out of that. And I'll make sure I get a note. I get a note on that every year. I'll make sure I get it to the DPRG list next time, because they can't get enough judges. And this is in town. It's at Fair Park, and they feed you breakfast and probably lunch. So, and you get to see all these maybe get a little hope that the world's not going to burn tomorrow, because these kids in here are trying to do something good. Now they may be going in the wrong direction a little bit, but that's all right. At least they're trying to improve stuff. A good number of them, Yeah.
I'm very appreciative of anybody who jumps into judging for those kinds of things.
Harold, what you said reminded me of my elder sister ran her own company for a while in France, of all places. And after she'd been doing it for a few years, she came home for a visit, and I said, "What have you learned running your own company?" And she said, "I've learned that what a leader does is make decisions. If they're good decisions, that's a plus, but it's not necessary."
Okay, anybody got?
So what did she do in France? What was her business?
She passed away here recently. She was a music historian, and she was head of the folk music collection for the Library of Congress in her last 10 years or so. And they did all these transcriptions of folk music and so forth for academic purposes. But she also said that her French employees would go away for lunch and come back 2 hours later drunk on wine and be useless for the rest of the afternoon. And when she complained, they would say, "Oh, you Americans, all you want to do is work. You don't know anything about life."
Okay, does anybody else have anything they want to share? Okay.
Class
All right.
dismissed.
Yeah, I think it's been a good meeting. I really enjoyed it, guys. I'll get these. I'm a little behind. Like I said, my wife started a new treatment series, so but should be able to catch up this week. So if you're looking for last week's video, we have it. It just hasn't been uploaded yet. Okay.
Later, dudes.
Sure.
Later, folks.
Well, thanks for the work, Doug, and good luck to your wife.
Thank you.